Hi guys, welcome to the lesson on rationalising the denominator with surds. Okay, we've been through this in class quite extensively. Basically, what is it? What first of all is an irrational number? An irrational number is anything with a root sign, pretty much. Okay, or most numbers with a root sign that they don't necessarily repeat themselves, and number continues on forever. So numbers like root 5. Root 7, root 3, root 2, okay, they're all irrational numbers. So if we have a question, for example, like this, for EG1, we might have 1 over root 3, and it says to rationalize the denominator. So what that means, that we want to make the denominator, which hopefully remember is that one there, okay, the bottom part of a fraction, the denominator, we want to change that from a surd to a non-surd, or a whole number. Now, how do we do that? Well, the idea, in order to create that, or create a whole number out of that number, we're going to square it. Because if I square it, which means we're timesing it by itself, root 3 times root 3, or another way of writing that is this. Hopefully you'll remember that the square and the square root sign are the opposites of themselves. So if I actually have a square root sign and then I square it, they kind of cancel themselves out, and we're left with that number. So in that example there, root 3 times root 3, or root 3 squared, is just 3. So what we are going to do, we're going to times the bottom number by the root 3, because we know by multiplying it by itself, okay, we create a whole number. But remember, what's the mighty rule that we have learned since about year 7? When you multiply the bottom part of a fraction, okay, remember when we are finding an equivalent fraction, we don't want to change the value of it. Whatever you times the bottom by, you must times the top. So now let's do that. When we multiply fractions, we times the tops times the bottoms. 1 times root 3 is simply just root 3. Root 3 times root 3, as we know, is simply 3. Okay, and that's it. That's our answer. Let's have a look at another one. We're going to have 6 over root 5. You might want to pause it and have a go at this one yourself. Okay, so we're going to multiply it by root 5 over root 5. So 6 times root 5 is just 6 root 5, and root 5 times root 5 is just 5. Done. Doesn't look too hard, does it? So look at another one. This one we're going to have a bit more challenging number. 2 root 3 over root 7. Okay, well, it's only the denominator that I'm looking to get rid of, the surd, the root 7. So we're going to times it by root 7 over root 7. Okay, we've got 2, and now I've got root 3 times root 7. Well, when we have the numbers underneath the root sign, we can just times them together. So 3 times 7 is 21, all over, 7. So it's just 2 root 21 all over 7. Now occasionally you can simplify that root 21 or root number down. If you can break up into a squared number, for example, say we had, let's think about it, the number root 20. If you recall, that means the same as 4 times 5, and we can actually simplify root 4 down. Square root of 4 is 2. That'd be 2 root 5, which is another lesson altogether. But if you remember that, that can occasionally go down. But at the moment, we're just looking at very simple and straightforward rationalizing one-digit numbers. Okay, what I'll do, we'll just write a couple of examples down here. So that was example 3. Okay, so 4. So have a go at these. We're going to do 3 over, we'll do root 11, 5 over root 3, and the last one we'll do 2 root 7 over root 2. Have a go at those three. Okay, the top one, we're going to times it by root 11 over root 11. So my answer is 3 root 11 over 11. The next one, times it by root 3 over root 3. We're left with 5 root 3 over 3. And the last one, we've got times by root 2 over root 2. So we've got 2 root 14 all over 2. Now that last one we can simplify. If we have, because they're timesing on the top, 5 times root 3, 3 times root 11, 2 times root 14, we can cancel some things out. For example, I have a 2 on the top and a 2 on the bottom. So I can actually multiply, cancel them out. So I'm actually just left with that last one, root 14. Look at that. And the only thing that can break up into 7 and 2, neither are square numbers, so we're done. Look, I hope this made a little bit of sense. Again, I've showed you the very easy surds. This is going to be a lesson now, hopefully that will roll into the trigonometry section using surds. But obviously it's a good reminder for previous surd work that you've done before.